Hi, I am Otanu. In this tutorial video, you learn the Surds and operation of the Surds. This is the series of the class 9 mathematics. Name of the chapter is number system. Here you learn the basic definition of the Surds and comparison between the radicals and also the different operations of the Surds like the addition, subtraction, multiplication. Find out the rationalizing factor of the shard, rationalization of the shards, square root of the shards. So I advise you watch this video till end so that you can start this exercise yourself. If this video is helpful to you, please subscribe this channel and share this video with your friends, and also like this video and press the bell icon so that you get the all updates. Let's start surds. Before start, let's quick recap about the radicals. So radical is the expression with the square root. So where there is a square root, you can say it is a radical. For example, say root 7, it is a radical. Root 7 is a radical. Expression. Okay, so what are the different part of the radicals? Let's take the general expression, and where we know that different components of the radicals. For example, if I consider a, and here the root power is n. So what are the name of the different parts? A, it is n. Okay, so a is actually any real number. Here n is index and a is the radicand. And this root is the to indicate the symbol of radical. So why it is so significant before start the surd? Because surd can be represented as a radical, but it is not the always true. For example, here the n is actually more than equal to 2. Okay. So what are the different examples of the radicals? Radicals examples are, if I told you root 2, it is a radical, yes. If I told you root 4, it is also radical. Correct. It is also radical. Root 7, already first example we have taken. Then root 3. So it could be any rational number as well as the irrational number, because root 4 is a rational number and root 2 is a irrational number. Clear? So in the algebraic expression, where these root symbols are there, root cube, 4 root something, some number. So I give you more examples here. If I told you 3 root 14, right, it is also a radical like this. So these are the example of the radical. we learn the surds. Okay, so when this radicand a is a rational number, and also and not in power of any rational number, then it is called the radicand. Surds, sorry, it is called the surds. What that mean? Let's take one example. If I told you root root 3, okay, so now you just compare with the n root a. Here n is how much? Here n is actually, consider n, here n is actually the 2. So, and also there is a root symbol is there, so it is radical, and 3 is the rational number. So all conditions satisfy here, so we can say that root 3 is a surds. Root 3 is a surds. I give you more example. If I told you 3 root 7, now here also all conditions satisfy. There is a root symbol, cube root 7, so n is actually any natural number, that is fine, and 7 is not the any power of cube, any power of the cube, right? So it is also, this part also satisfy. Okay, so it is a, and 7 is actually the rational number, so all conditions satisfy. Root 7 also a surds, also a surds. I give you the another example. If I consider root 3 plus 2, or you can say same as 2 plus root 3, root of 2 plus root 3, or you can write here the any root, that is 5. Okay, so why it is not the surds? Because the a term, find out the a term, this is the a term, so we can represent as n to compare with this term. So here a is actually what? A is actually 2 plus root 3, so it is not a rational number. It's a irrational number, so it is not a surd. So sorry, it is not a surd. Yes, not a surd. So I give you another example. We know that pi is the irrational number, so it is not, if I told you root pi, it is not a surd. Okay. And pi itself also. Okay. Clear? So what that mean? A general expression. So if I told you, for example, when the a is rational number, and not power of n, not in power of any rational number, means we can't express this term as a next to power n. We can write this. So when this condition satisfied, then we can say it is a Surds. Clear? So we can say this statement that every Surd is the irrational number, but every irrational number is not Surd. For example, I or root 2 cube root of root 3 plus 2, 5 root of 2 plus root 3, like this number, where the inside the root or the radicand, the root is called the radicand, but the radicand is irrational number, then that kind of the number is itself is the irrational number, but not the Surds. Is clear? So next we learn the type of Surds. Next we learn the under this type. First is unit Surd. And multiple of unit Surd. Okay, let's take one example. If I told you root 3, it is a unit Surd, and it is a unit Surd. If I told you 2 root 3 or 5 root 3, it is the multiple, not it is here, it is not here. Root, it is not the root part, it is the multiple part, meaning actually it is 5 into root. Okay. So it is called the multiple of the unit. Okay. Next we learn the mixed Surds. Let's take one example, 2 plus root 3. 2 plus root 3. So it is a mixed Surd. Or 5 minus root 7. This is not the pure Surd. Here these are the pure Surd. Okay. These are the pure Surd. Clear? So in general expression we can write the pure Surd as a root n root a. This is the pure Surd. You can say the unit Surd also. And if I write multiply with some natural number, then we get it is a mixed Surd. So not the mixed, it is the multiple of the unit Surd. Here the two parts is there, one is rational and another irrational part. So you can say it is a mixed Surd. One is this part is the irrational part and this part is rational. Next we learn the compound Surds. You can write a general expression as, for example, n root a plus m root b. two units are when plus minus. When add or subtract, then it becomes the compound. For example, if I told you 5 root 7 minus 3 root, these are the example. Then we learn the binomial sort. When two monomial shards add or subtract, then it's become the binomial shards. So these are the example. If I told you n for the general expression n root a plus k m root b, these are the example of the binomial sort. For example, if I told you root 3, this is for example 3 4 4 5 5 root 3 5 root 3 plus 7 root 2. These are the binomial sorts. So both are the, these are the monomial sort, these also monomial sort, then add together it's become the binomial sort. Okay. So here it is the monomial sort. This form is the monomial sort also. Monomial sort. Clear? Next we learn the similar sorts. So what are those similar sorts? So similar sorts are if it is the monomial or the, you can say the unit sort or the multiple sort of multiple of that unit sort, then it is the monomial. Means if I multiply root 2 into 5, then these two sorts are the similar. Similarly, if I consider 2 root 3 plus root 5, and another is 4 root 3 plus 2 root 5, because here the multiple of what, this is a sort, is a multiple of 2, so both are the similar sorts. Clear? What is the significance of this similar sorts? We can add or subtract in between the similar sorts. Now we can use the laws of radicals for the operation of the sorts, or simplification or the calculation of the sorts. So what are the laws of operation, laws of the radicals? So suppose it is n root a, if we multiply into n root b, we can simplify as n root ab. Okay, and also n root a divided by n root b, we can simplify as the n root of a by b. Clear? Then if it is n root m root a, we can write as, you can change the position, that is here it will be m and here n. You can change the position of the roots value, and then also you can write as mn root a. Okay. Another is n root a to the power p, we can write as a to the power p by n. Okay, and n root a to the power p we can write as, if we multiply, if not multiply, you take the power of m, then we can reduce it by taking the roots, and again the outside we can take the n. Clear? This. The general expression, we write sort as n root a, n root a, sorry, then the order of this sort is actually n. So for example, if I told you what is the order of this sorts, the answer will be 3. The order is 3. Okay, and if I told you what is the order of 2, here it is actually the 2, because root 2, the n here is the 2. So why order is so important? So we can compare the unit monomial sorts by the taking the order same. So next we discuss this comparison of the monomial sorts. How you can compare between the two monomial sorts? Let's take two example, that is 3 root 2 and 5 root 7. So how you can do that? First we have to take the degree. Okay, so or the order, this order 3 and 5 is different. Let's take this order 3 and 5 and take the LCM. The LCM of the order of 3 and 5 is what? 15. So now convert this given monomial sort into the same order. I can do that. So 3 root 2 is equal to, if we consider 15 here, then it will be what? It will be 2 to the power 5. Why? Because this rule we can apply. Sorry, it's not moving. This rule can apply. If we multiply something, this one, then you have to write here. Okay. So for example, if I consider, suppose it is given a, and if you have to multiply into m, then you have to do same thing, a to the power m, you get the same result. Okay, so it will be 2 to the power 5, and next is what? Next is 5 root 7 is equal to 15, and it will be what? 5 it is here, so 3, 7 cube. Clear? Now 7 cube is what? 49 into 7, and 2 to the power 5 is what? 32. So it is very much clear that 7 cube greater than 2 to the power 5. Okay, so for the same order you can write as is also greater than what? 15 to the 5. So we can write as 5 root 7 5 root 7 is greater than 3 root 2. Clear? I already discussed that what is the similar sorts, and addition and subtraction, it is possible in between the similar sorts. For example, if I told you that 2 root 5 plus 3 root 5, what will be the value? We can add it actually, 2 plus 3 plus 2 by the taking common root 5, so it will be 5 root 5 is the answer. So it is possible. So the general expression, we can say that if I told you here it is x, or take n here, n plus minus, you can say x, and it is for example it is a, and it is n, it is b. Okay, so we can write as a plus minus b in x. Clear? Okay, if the order of the monomial sort is same, then we can apply this law. This is law you can apply. Here n is actually means the order is same for the two sorts, so we can apply this. N, for example, if it is a, multiply with n, it is b, then we can write as ab. Clear? And also we can apply for the division, n root a and n root b, we can write as n. The radical formula we can apply, radical law we can apply. Clear? Let's take one example. That is question given that divide 6 root 5 by 3 root 10. How you can do that? So 6 root 5 divided by 3 root 10. This is the question. So then LCM of 3 and 6 of order, to make the same order, 6 and 3 is equal to 6. Okay, so it will be remain the same, and it will be, if we write 6 here, then we multiply square, then it will be 3. Okay, the same rule. If it is n, then we can write as mn a to the power m. Clear? Same formula we apply here. Then we get 6 root 5 by 6 root means 100, then we get 5 by 100, total roots 6 root 5 by 100, then 6 root 1 by 20. So this we get from this radicals law, that is if the order is same, a to the power n by b to the power n, then we can write as ab to the power, sorry, not power, we can write as, here. Next we learn the rationalizing factor or RF of the Surds. So what is RF or rationalizing factor? So it is also a Surds that we multiply with the given Surds, we get a rational number. Okay, So if we multiply one Sard with a RF, we get a rational number. For example, if there is a Sard that is 3 root cube root 2, okay. So what is the RF? So to find out the RF, what you have to do, next convert it to 1 by 3, then RF is equal to 2 to the power 1 minus 1 by 3 is equal to 2 to the power 2 by 3. Clear? So it will be what? 3 2 square. Okay. Now, as per the definition of this, what we can do, just multiply. If we multiply the given Sard into the RF is equal to what value we get? We get this multiplication 2 into 2 square. Okay, 2 into 2 square. So since the order is the same, we can inside multiplication, then it will be what? 2 cube 2 cube, yes, it will be 3 into 1 by 3, we get 2. Clear? So the RF is here. This is the RF. Clear? So in the general expression, how you can find out the monomial Sard? For example, if I told you n to the power n root a, what will be the RF? The RF of is equal to a to the power 1 minus 1 by n. Clear? This is the RF. Why? Because if we multiply this with this, what value we get? N root a into a to the power, here you can write as n a to the power n minus 1. Clear? So n a to the power n minus 1. Since the order is same, you can multiply both a to the power n minus 1. Okay. So it will be what? A to the power 1 plus n minus 1, then n root a to the power n. 1 cancel out, then it will be a. We get a rational number. Clear? So we can say that rationalizing factor of n root a is equal to n root a to the power n minus 1. It is clear? Now by applying this algebraic identity, we can find out some binomial Surds RF. Okay, for example, if the question given what is the RF of this, how you can find out? The RF of root a minus root b is equal to what? Is equal to root a minus root b. Why? Because if we multiply both the given Sard into RF, we should get a rational number. Then it will be the RF. So let's check whether it is satisfied or not. So if we multiply root a plus root b into root a minus root b, then we get root a square minus root b square. A plus b into a minus b, we get a minus b. So it is a rational number. It is a rational number. Clear? So we can say that. So we can say that root a minus root b is RF of root a plus root b. Okay. Let's take one example. If I told you what is the RF of root 5 plus, or if we consider minus also, consider minus root 5 minus root 3, what is the RF? What is the RF? How you can find out? We are applying this concept. So RF is RF of root 5 minus root 3 is equal to root 5 plus root 3. Why? Because we can prove that if we multiply with the given sort, that is root 5 minus root 3 into root 5 with the RF value, then we get 5 minus 3. So 2 is a rational number. Okay. Done. Let's answer this question, that is rationalizing the denominator. Rationalizing the denominator means this part we have to rationalize. So here we get, here after the rationalizing the denominator, we get the one rational number on the denominator side. So how you can do that? First we have to find out the RF of the denominator. RF of 3, 5. How you can find out? We know that we get it is at 5 to the power, we know that is 325. We can write as 3 root 5 square, so that is 5 to the power 2 by 3. So this number is actually what? This number after find out this, then easily we can find out the RF also. So 5 to the power 1 minus 2 by 3. Okay, so it will be what? 5 to the power 1 by 3. So this is the RF of the denominator. Then we, if you want to rationalize the denominator, then what you have to do? We have to multiply both. Multiply with the denominator. Clear? So what will be the answer? First we write the given question, that is 2 into 3 root 7 divided by 3 root 25. Then both numerator denominator we multiply with the factor, that is 325 into, what is the factor? That is 5 to the power 2 by 3. Here 5 to the power 2 by 3. Clear? So here we will get 237 into 5 square 3 root 5 square, and here we will get 5 to the power 2 by 3 into 5 to the power uh, so RF factor is not 2 by 3, it is the 1 by 3, sorry, it's by 1 by 3, because we get the RF here 1 by 3. Okay, so here we'll get 5 only. Done. This is 1, this is 1, so here we get 1 by 3. Now the numerator side we get, because the order is same, so we can multiply inside the root. So 3 root 5 into 7 into 5, clear, and here we get 5 2 by 3 plus 1 by 3, it will be 5. So the numerator will be 35 and denominator will be what, 5, clear. This is the answer. So what is the RF of the mixed sort? So let's take the general expression, that is, if the sort is a plus root b, then RF will be, this is the given sort, and the RF of a plus root b will be what, will be a minus root b, and vice versa. If it is minus, then it become plus, clear. Now how we can rationalize the this kind of the mixed sort denominator? Let's take one example. Let's take one question, that is rationalizing the denominator of 2 plus root 3 and 2 minus root 3. How you can do that? We have to find out the RF of the denominator. So what is the RF of the denominator? RF of is equal to what? Is the conjugate or the RF. Okay, 2 plus root 3. Now what you have to do? First write the question, that is 2 minus root 3, and what you have to do? 2 plus root 3. We multiply numerator, both numerator denominator with the RF. So RF is what? 2 plus root 3, and here also 2 plus root 3, clear. So here we get that is denominator is get 2 square minus root 3 square, and numerator we get 2 plus root 3 whole square. So what value we get? This is 4 plus 3 a plus b whole square, a square plus 2a plus b square, plus 2ab, 2 into 2 4 root 3, clear. And here we will get 4 minus 3, it is 1, so 7 plus 4 root 3. This is the answer, because denominator rationalize, it's become rational number 1, clear. It's become 1. This is the answer. Let's take another example. Find out RF of let's take example 3 or not 5 to the power 1 by 3 or plus 5 to the power minus 1 by 3, or you can say it could be like this, 3 root 5 cube root of 5 plus 1 by could be plus 2, okay, that is, just a minute, cube root of 5. So how you can do that? Question may be in this form also or this form also. So how you can find out the RF? So first we have to apply this by looking this cube root. We have to remember this formula, algebraic identity, that is a cube plus b cube since a cube plus b cube is equal to a plus b into a square minus ab plus b square. Means if we find out a square minus a plus b square by assuming that a is equal to 5 cube root of 5 and another value is the b, that is 5 to the power minus 1 by 3. So means actually for your understanding, here a is equal to what, 5 to the power 1 by 3, and b is what, 5 to the minus 1 by 3. And if we find out this value, this a square minus a by b square, this will be the RF. This is the RF portion, okay, because a plus b is given. So RF. So the answer is actually the RF of 5 to the power 1 by 3 plus 5 to the power minus 1 by 3 is equal to a square. That is a square means what, a square minus ab 1 by 3 into 5 to the power minus 1 by 3 plus b square 5 to the minus 1 by 3 here whole square. So it will be what, 5 to the power, you can write as 2 by 3 minus 1 by 3, 1 by 0, so 5 to the power 0 is equal to 1 plus 5 to the power minus 2 by 3. Clear? So we can write as 25 cube root of 25 minus 1 plus other you can write as, or since the question is given, you can write as this or this. This could be the answer, or this will be the answer by cube root of 25. Clear? 25. So any form could be the any answer. This is also answer. Clear? Done. Why it is? Because if we multiply a plus b, then we get the a cube plus b cube. Then what we will get? We get a cube plus b cube. Then we get 5 to the power 1 by 3 a cube plus 5 to the power minus 1 by 3 cube. Okay. So what value we get? It will be 5. And it will be what? It will be 5 to the power 3 by 3, 5 to the minus 1. Minus 1. Clear? So it will be 5 plus 1 by 5. So this is a rational number. Clear? So this is not the answer part. Answer part is only this portion. So you have to find out the a square minus a plus b square. Clear? Next we learn the square root of the quadratic shard. So quadratic shard means the shards that contain the square root. Means if we say that for example a root b, since it's contain the square root, so this is the example of quadratic shard. Okay. Right? Quadratic shard. So how you can find out the square root of the quadratic shard? So we apply this concept, that is, let's root of a plus root b is equal to root x plus root y, then both side squaring, what will get? By both sides squaring we get a plus root b is equal to root x plus root y here whole square. Clear? Whole square. So next we get a plus root b is equal to x plus y plus root xy. Then from here we get x plus y is equal to a, that is 1, and another is uh, 2 root xy, 2 root xy is equal to root b. Okay, from 1 and 2 equation, by solving these two equation, by solving the equation 1 and 2, we can get, we get the value of the root x and the root y. Clear? Value of root x. So let's take one example, that is uh, find out the uh, square root of the Surd quadratic Surd, that is 7 plus 4 root 3. How you can find out? So let's consider, let root of 7 plus 4, it's not here, 4 it's not here, actually not the root position, 4 would be here, 4 it is 4, root 3 is equal to root x plus root y. Okay, so squaring both sides, what will get 7 plus 4 root 3 is equal to x plus y plus 2 root xy. Why? Because a plus b whole square, we are applying the a plus b whole square is equal to a square plus b square plus 2ab. We are applying the algebraic identity here. Clear? Then compare the both rational, the irrational part. We get by solving, first we compare it, this is the rational part, we get x plus y is equal to 7 and 2 of root xy is equal to 4 root 3, and if we square it, it will be what, 4 xy is equal to 16 into 3. Okay, so cancel out, so it is 12. Okay, xy is equal to 12. So from this, if we consider x, if we consider if we x is equal to 3 and y is equal to 4, then both these equation will be satisfied. So then x plus y is equal to 7 and xy is equal to 12, both equation satisfy. So x and y is the solution. Okay, x and 3 and y is equal to 4 are the solution of x plus y is equal to 7 and xy is equal to 12 of these both equation. So finally we can write as 7 plus 4 root 3 root is equal to root x plus root y and replace with the x and y with the value, we get root 3 plus root 4. Okay, root 3 plus root 4. Done. So root 4 is what? 2. Root 3 plus 2 is the, or you can write as 2 plus root 3 is the answer. Okay, done. Now we learn the square root of the trinomial quadratic surds. So let's consider the general expression, that is a plus root b plus root c plus root d. Since these three are the surds, quadratic surds. Because these three value having the square root and they are the irrational number. Clear? And where a is the rational number, a is the rational number. So if we find out the square root of this number, then we can assume this number as a root x plus root y plus root z. Now how we can find out the there is a you apply this hashtag AD shortcut. How you can remember this? So since BCD represent with the x, y, z, so you draw this cycle, that is A. First you write down not the A, first you write down the x, then the arrow y, then the arrow z. Now here you write x is what is connected to the B, and this is C, and this is D. Okay, so this is the cycle. Cycle is clear. This is the cycle, anti-clockwise. Okay, then how we can find out the x? The x will be first you write down the this root, and then is write down this, that is c value, and here you put in half, and you put the x target to c. Here it is arrow x target to c, so denominator side you just write down the c only. Clear? You write down the c only. Okay, so these are the entire root. Remember this, don't do any mistake. Now what remain? Remain this ABC cycle remain is BD. Okay, so you only write down the BD. Clear? So half of BD by C, that is the value of x. Similarly, if we follow the y, then write down half root of, then B, this y target to what? Target to z. So y target to z. Okay, not z, that is D. We are in the D, and here just a minute, and D and BC, that is BC. What remain? BC. Okay, and what is the value of z? Z target to B, so half and root, and here you write down the B, and what remain? A, C, D. Clear? This way you can find out the solution. Okay, x and y. What is the another method? Second method, number 2. This was the method 1. method 1. What is the method 2? So method 2, let's take one example, that is, let's take this example, that is, find out the square root of 10 plus root 24 plus root 60 plus root 40. Okay, so this is the trinomial, because three surds are there, trinomial, quadratic surds. Okay, square root of the trinomial quadratic surd. How you can find out? So simply you can do this. It is 10 plus, and if you simplify this surd, so this is 6 4 ja, so you can find out the 6, 2 root 6, and here you can write as what, 60 you can write as, this is 24, and 60 you can write as, so 15, right? So 215, and here you can write as 40 is equal to, that's 40 is equal to 4 into 10, so it will be 4 into 2 into 5, correct? 2 into 5, so it will be what, again it will be 2 into 2 into 5, correct? So now remember this algebraic identity, that is a plus b plus c whole square. We know that a plus b plus c whole square, a square plus b square plus c square plus 2ab plus 2bc plus 2ca. Okay, so we can apply this, find out the value of the abc, correct? I can do that. So first you split the 10, 2 plus 3 plus 5. Okay, then you square it, a square, b square, c square, so make it clean. Next is 2ab, 2 into root 3 into root 2, so we get root 6, 2 root 6 plus 2 into ab bc, root 2 into root 5. Okay, correct? And next is 2 into ca, that is root 5 into root 3, so it is actually middle term. You can change the position a b b c c a, so ultimately you get root 3 plus root 2 plus root 5 here whole square. Clear? And you get the final value, that is root 3 plus root 2 plus root 5. This is the final. Thank you for watching this video, and hope your concept is clear about the surds, and you can apply to doing your exercise. So please share this video with your friends if it is helpful, and see you in the next video. Bye.